What is going on, everyone? My name is Kodamore and welcome back to the New Beginner Java Game Programming Tutorial Series, episode 31. In this episode, we are going to work on close range combat, which will essentially allow our player here to fight entities. So I can walk up to this tree, punch it a few times, and then I'll kill the tree, and the tree will disappear. And then in the following episodes, we are going to learn all about items, so that once we do kill this tree, it'll drop maybe a few logs, and we'll have an inventory, crafting, and all of that fun stuff. But first, we're going to work on this close range combat, which actually isn't that hard to do. So I'd like to point out that I have added a new entity to my game. It's called a rock here. Again, not the greatest texture, but essentially I've just added a rock class which looks exactly like the tree class, just with a different texture and size. And then I've added a rock to my world temporarily, just like I've added a tree to my world. Also, in my menu state here, instead of having the user click the play button to begin, just for development purposes, the second that the menu state enters the tick method once, I'm just automatically going to switch right to the game state. That way I don't have to go through the menu state every time I want to check if my game runs correct. Alright, let's get to this close range combat. Firstly, you can do combat in many different ways when it comes to controls. You can keep track of which direction the player is facing and have one button to activate an attack in that direction. Or you can do it like I'm going to do it. Basically, I'm going to move the player with WASD, as you can see down here, but I'm going to use the arrow keys instead to attack in a certain direction. So I can be moving up and I can be holding the right arrow key, and that will allow me to attack to the right. So I will be using the arrow keys as my attack buttons. Again, you can do it differently, keep track of the direction of the player and just attack in its current direction. So in order to keep track of these controls, I'm going to create some more public booleans. I'm going to call this A up, A down, A left, and A right. And these are going to be for my attack buttons, which will essentially be the same thing here in the tick method. I'm just going to set those variables, make sure I rename them correctly, and then I'm going to change the keys that activate them to up, down, left, and right, like the arrow keys, like so. So now in my key manager class, I just have a few booleans for my attack keys. If you're only going to have one button to attack, then of course you only need one boolean for your attack button. Alright, next in our creature class here, we have our creatures having a health variable. And this is my mistake. Actually, every single entity should have a health variable. So we're going to move this protected int health from the creature class here, and we're just going to move it right on in to the entity class. That way every entity has a health. I'm also going to move this default health final variable into the entity class as well there. And finally, in the creature constructor here, where we set health equal to default health, we are instead going to move that, as you guessed, into the entity constructor. So now instead of just creatures having health, every single entity will have a health variable. We are going to add another variable into the entity class, and that's going to be a protected boolean variable called active, and we want to make sure that we set this equal to true to begin with for every entity. Basically, whenever we set active to false, we're going to add some code to the entity manager that removes that entity from our game. And of course, whenever we create an entity, we want it to be active, so we set it to true to start. Now I'm going to go ahead and generate some getters and setters for our health and for the active boolean variable. You guys know about getters and setters, so I won't even show them. Next, we're going to add another method to our entity class, and that method is going to be a public void hurt method. So essentially, hurt is just going to take in some amount, and it's just going to decrease the entity's health by that amount. So we're going to subtract from our health variable of this entity whatever amount is passed into this hurt method. Now, once health reaches 0 or goes below 0, so if health is less than or equal to 0, then the entity should die. And we just handled a way to do that. All we have to do is set active equal to false, and eventually when we add the code to the entity manager, it will remove the entity from the game. So if health is less than or equal to 0, we're going to set active equal to false. So it will eventually be removed from the game. And then we are going to call the die method. Now we don't have the die method set up, but instead we are just going to create an abstract void method called die. And this will be called, obviously, once the entity dies right before it gets removed from the game. And we're making it abstract, that way every entity has to implement its own die method. So that's it for the entity and creature classes. Of course, now we have a bunch of errors in our player, rock, and tree class, or any other entity that you might have, and that's because we have not implemented the die method. So I'm just going to, in every class below the tick method, I suppose, I'll implement that die method, public void die, and we don't need anything in there. I suppose I'm in the player class right now. When the player dies, we'll just system.out, println, you lose So whenever the player dies, we'll just print out you lose for it right now. And then go ahead into your rock and tree classes, and I'm just going to paste that die method in here. Oops, I forgot the override notation. You don't need this, but I prefer to put them. There we go. And I'll paste that into the rock class as well. There we go, and I will add this to the player. Now all the errors are gone. Essentially, we've just added a die method to every single entity in our game, and eventually we can use that. For instance, when the tree dies, before it gets removed from the game, it might spawn a few items that the player can then collect. So back in our entity class here, whenever our health goes below 0, we call that die method of the entity, and we also set active equal to false, meaning that we want to remove it from the entity manager. So head on into the entity manager here, and after we tick an entity, we are going to check if E.is active, rather not. So if E is not active, so we've set it equal to false, then we want to remove the entity. So we're going to do entities.remove E, like so. And that should successfully remove that entity from our entity manager. Alright, so that's all that base setup stuff. Now all the work that we're going to be doing is inside of the player class here. First, let's make sure we run our game and everything still runs properly. Of course, yes it does. Now, right at the end of tick here, we are going to handle all of the attack input and actually attack. So I'm just going to call the check attacks method, which we have not made yet. So right here, I'm going to make a private void check attacks method, like so. So here we are going to check if the user is pressing the attack key, and then we're going to generate the actual attack that we're going to do. But first, let me show you a quick diagram about this. So since we're only working with close range attacks and nothing like bullets or anything, the way that we're going to handle checking if the player actually hits an entity when he attacks is very simple. First of all, I'm going to highlight my player's collision box. So I believe my player's collision box is something like here. This blue box right here. Next, what we're gonna do is whenever the player is pressing an attack button, so let's say that my player is pressing the down attack button, what we're gonna do is we're gonna generate a temporary imaginary rectangle, sort of. So if he's attacking downwards, I'm gonna generate a little imaginary rectangle right here in red, and then we're gonna check if any entity intersects with this rectangle. If it does, then it means that our player hit it, and it should then attack that entity and hurt it. So for instance, if my player decides to attack towards the right, then we're going to generate a temporary rectangle to the right of the player's box here, and we're going to check, does this rock entity intersect with this rectangle? In this case it does, so we would register an attack with the rock, and we would then hurt the rock and damage it. The same goes for up. If we attack up, we're just going to generate a temporary rectangle here, and left, we're going to generate a temporary rectangle here. And we're going to do it in relation to the player's collision box right here, and not the entire image of the player. So it's as simple as that, is generating a rectangle below or on the sides of the player and then checking if any entities intersect with it. So let's head back into this check attacks method and let's get coding. First, we're going to need a rectangle, which I'll just call AR for the attack rectangle, which is essentially going to be that little red rectangle that I drew in the diagrams. And we'll set that equal to a new rectangle object. Go ahead and import that. Then we're going to create a variable. It'll be an integer called AR size. This will be the size of that little attack rectangle. So I'll set that equal to, I don't know, 20 pixels for now. This way, if the player is within 20 pixels of an entity, and he attacks in the direction of that entity, it should be able to hit it, but if it's further than 20 pixels, it won't. Again, that's just the size of the red rectangle on the side of the player. You can adjust that value to your liking after we get it working, of course. Now the width and height of our attack rectangle is going to stay the same. So we're going to set the width of that attack rectangle equal to AR size, as well as the height equal to AR size, because those will never change. Next, we're going to have to check the direction of the attack of the player, which direction the player is planning to attack in. So firstly, we're going to want to get the collision bounds of our player itself. So right here at the top, we'll create another rectangle, which I'll just call CB for collision bounds, and that will be equal to the get collision bounds method, and we don't need any offsets or anything like that, so we'll leave those at 0. This will just get us the coordinates of the collision box for our player. Now we can begin checking where to draw that attack rectangle, where to draw that little red rectangle that we drew in the diagrams. Now the way you do this depends on how you're going to handle attacks. In my case, I have arrow keys, and depending upon which arrow key you're pressing is the direction of your attack. So in my case, if handler.getKeyManager, .a up, which is my attack up key, is being pressed, then we're going to do something. Now if you were storing the direction that the player is facing, then you'll simply check if the single attack key is being pressed, and then have if statements depending upon which direction the player is facing. So if my player is attacking upwards, we're going to have to set the X and Y values of the attack rectangle properly so that it draws just above the collision box of our player. And this will simply be our collision bounds.x, so essentially the X coordinate of our player. Whenever I say player from now on, I mean the collision bounds of our player. So the X coordinate plus half of the width of our player. So this will essentially get us the center X coordinate of our player of our collision bounds. Except when we draw the rectangle with a width of AR size, it will no longer be centered. So we have to subtract half of the AR size from that. This way when we draw, and we're not actually going to draw it, but this way when we check the attack rectangle bounds, it will appear centered on the player. So essentially, cb.x plus half the width of cb is essentially going to get us the center X coordinate right here in our collision bound. Then when we subtract half of the collision bound size, we're essentially going to get a coordinate somewhere over here. If you guys don't understand that, if you draw it out on paper, you'll understand it right away, trust me. It's just some basic coordinate system math. Then we're going to set the Y coordinate equal to the Y coordinate of our collision bounds minus the size of our attack rectangle. This way when we draw it, again, it'll appear right above our collision bounds. And we don't have to set the width and height because those stay the same and we already set them up here. Next, we're going to copy this down in a bunch of else-if statements because I only want my player attacking in one direction at a time. So we're going to check everything up, down, left, and right. Okay, there we go. Now I'm checking down, left, and right as well. Now, when I'm attacking downwards, our X coordinate is going to stay the same. That way we center it and everything correctly. But our Y coordinate is going to change. We're going to do the Y coordinate of our collision bounds. We're going to add the height of our collision bounds as well. This way, when we draw it, it'll appear below the collision bounds instead of above, like when we were attacking upwards. Now, when we're attacking to the left, we're going to have to change a few things. When we're attacking left, we're just going to take the X coordinate of the player and subtract the size of our attack rectangle. So that'll get us to the left, and of course, we're going to have to change the Y coordinate now to center it. So in this case, it'll be cb.y plus half of the height of the collision bounds minus half the size of the attack rectangle. And I'm just going to go ahead and copy this part right here and paste it right down below in the right because it will be the exact same except the X will instead be cb.x plus cb.width. Then we're going to add an else statement here. So if none of my attack buttons are being pressed and the player isn't attacking at all, we don't want to run any of the other code that we're about to write in this method, so we're just going to return. So basically, if none of these if statements run, then we'll just return from this method and do nothing because we're not attacking. However, if one of these if statements did run and we did set the coordinates of the attack rectangle, then below here we can now begin checking for the attacks. First things first, we have to loop through every entity in our game. So for entity E in handler.getWorld.getEntityManager.getEntities, so for every single entity in our entity manager's array list, that's simply what we're getting here is the array list in our entity manager class. So for every entity, we're going to first check and make sure that the entity isn't ourselves, that it's not the player. So if e.equals this, so if the entity is this player class right here, then we're just going to continue because we don't want to accidentally hurt ourselves with our own attack. And continue basically means skip the rest of the code in the for loop and just go and loop through to the next entity. So if the current entity that we're looping through isn't ourself and it is a valid entity, then we're going to check and see if it intersects with our attack rectangle. So if e.getCollisionBounds with a 0 and 0 offset dot intersects with our attack rectangle, this means that we've hit this entity. Our attack rectangle is overlapping with this entity, therefore we should hurt it. So we're just going to do e.hurt, and for right now we'll just hurt it with a value of 1. Of course, in the future this will change with what item you have equipped and everything like that. But for right now we'll just hurt it with a value of 1. And then we're going to return from this entire method. Because I only want my player to be able to hurt one entity at a time, so once we hurt an entity with this attack, we'll just return and we'll have to wait for the next tick method run to attack again. Great. That is it. That is essentially the completed check attacks method for the time being. If we go ahead and run our game now, no, I've actually made a huge mistake. I just got really confused for a second. Basically, when I'm attacking right, we have to add cb.width, not subtract it. My apologies. Now everything should work. If we go ahead and run our game now, and we walk up to a tree, everything will still work. If I hold the right attack button right now, obviously nothing happens because we're to the right of the tree, and we're trying to attack right where my mouse is here. But if I hold the left attack button, as you can see, the tree disappears because we hurt it enough. Its health was decreased to 0, and the entity manager removed it. So let's say if we go into this rock, if I hold the up attack button, for instance, nothing happens because we are above the rock. But if I hold the down attack button, the rock disappears because we attacked it correctly. This is great, guys. Now we have a working close range attack for our player. Except, did you guys notice how fast those entities disappeared? They disappeared almost right as I hit the button to attack them. And I don't want this. I want to limit the speed at which the player can attack. Because right now, every time this check attacks method is running, which is every time the tick method is being called, we are allowing the player to attack. So we're going to add a time limit on how fast that this player can attack. So up at the top here, we're going to create a few more variables. I'll call this attack timer. So we're going to have a private long. We're going to have last attack timer. We'll have an attack cooldown variable, which I'll just set to 800 for now. Remember, 1000 is 1 second in milliseconds. So by setting this to 800, I'm saying after 800 milliseconds, we'll allow the player to attack again. So essentially, the player has to wait 800 milliseconds between attacks in order to attack again. And then we'll have the regular attack timer, which we'll set equal to the attack cooldown to begin with. That way the player can attack right as the game starts. Now, the code that we're going to write is going to look almost exactly the same as in the animation class. So if you're confused with any of the math that I'm going to do, just take a look back at the animation class and it should all come back to you. So at the top of check attacks here, we are going to update that timer. We're going to say the attack timer, we're just going to add to it the current millisecond time minus the last attack timer time. So we're essentially adding to the attack timer the time elapsed between these two method calls. Then we're going to set our last attack timer equal to the current milliseconds. That way we're all set up for the next call of this method. Now we're going to make sure that the player is eligible to attack. So if the attack timer is less than the attack cooldown value, so if the attack timer has not been running for 800 milliseconds or more, that means the player has to wait a bit more to attack. So we're just going to return right away and not run any of the below code. However, if attack timer is greater than the attack cooldown, and we have waited longer than 800 milliseconds, then the player is eligible to attack and we will run all of this code right here. Now, once we get to the bottom of all these if statements, which means we have run one of these if statements and we haven't returned from the method, obviously, we're going to set our attack timer equal to 0 again. Because this means that our player is going to attack right here, and we want him to wait another 800 milliseconds before he can attack again, which is handled by this if statement right up here. Again, very similar to the animation class, but now if we run, it will take us much longer to attack this tree. So I'm going to hold my left attack button right now, and as you can see, it's taking much longer to knock down the health of this tree. But this looks really boring, and there it goes. That took much longer because we added that timer. And of course, you can adjust the attack cooldown value to your liking. And maybe certain items in our game can change this value so you can attack faster or slower, and things like that. Now, that looked really boring though. I can't even tell when the player is attacking. Now, this is a challenge to you guys. Whenever you guys run an if statement and check if the player is going to attack, and it does attack in the proper direction, in your render method, I challenge you guys to render something that makes it look like this player is attacking. Maybe render a different attacking animation, or maybe render a little image below or at the sides of the player to indicate the direction that he's attacking. So that's a little project for you guys. I'm not going to teach you guys how to do that unless you guys really want me to, but trust me, it's a great exercise. Go out and try and make it a bit more visually appealing when the player actually attacks an object. So, we're able to attack objects now, but once this rock disappears, I want a reward. I want items to fly out of that rock and me to be able to craft some things. So that's what we're going to be working on in the next few tutorials, guys. Thanks for watching, everyone, and I'll see you guys in the next episode.